In this lesson, we're going to examine an arithmetic series. An arithmetic series is the sum of an arithmetic sequence. So the sequence is a pattern itself, 1, 3, 5, 7. The series is going to take those numbers and add them all together. So 1 plus 3 plus 5 plus 7. And so same ideas as we looked at yesterday. They have a starting value, they have a common difference. They have to go up with the same amount each time. They have a certain number of terms, but instead of just figuring out what they are, we want to figure out what they add up to. So a new equation for us. Sn is going to stand for the sum of n terms. We have to know how many parts and pieces there are to this sequence first. And we're going to see that another n a few times. Right? N could be divided by 2 outside the bracket. 2 times our first term plus n minus 1 times our difference. So the only new letter is the S. Everything else is the same, just there's more parts and pieces to them. So look at an example to get ourselves started here. So find S20 for the sequence given here. So S20, the sum of the first 20 terms. We're going to take 20 divided by 2 times 2 times U1. U1 is our first term, plus n was 20, times our common difference. And we notice it's going down by 6 each time. So what I like to do when I do the math for this is I figure out the 3 numbers I'm going to need. 20 divided by 2 is 10. 2 times 7 is 14. And in the bracket, 19 times negative 6 is minus 114. All right. And then do my little calculation inside the bracket, a little bit of bed mass. And I end up with negative 1,000. So if I were to type in my calculator, 7 plus 1 minus 5 minus 11 minus 17 minus 23, so on, so on, so on, for the first 20 terms, it'd come out to negative 1,000. It's okay to have negative numbers because our numbers are going down each time. That's not a big deal. Okay, let's try the next one. Find the sum of the sequence defined by this series of numbers. 7, 14, 21, 1, dot, 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 up to 175. The difference here is I don't know what I need to find the sum of n, but I don't know n terms. Whenever we don't know how many terms we have to go back to yesterday's equation, the un one. If I want to know anything about the sequence, this is the formula I need to use. Because I know the first term, I don't know how many there are, I know their difference is 7, I know my last term comes up to 175. I want to know the n that goes along with it. So I have to solve this. So we're going to expand our brackets. This is kind of nice so the 7s cancel each other out. And then solve for n. And n comes out to 25. There's 25 terms in the sequence. Well, now that I know that, I can find the sum of those 25 terms using our new equation. 25 over 2, 2 times the first term, plus 25 minus 1 times our difference. And we'll do the math where we can do the math. So I got 12.5, 14, and then 24 times 7 is 168. And I punch that on my calculator, and I end up with 2275. So again, if I don't know anything about the sequence, how many terms there are, what a term is, the difference in the sequence, I use my U equation. If I want to figure out the sum of it, or I know something about the sum of it, I have to use the S equation. Now, there's a bit of a shortcut. If you actually look closely at that equation we just dealt with, our S equation, you might notice that there's something kind of familiar in here. We've seen some of those same letters before. In fact, if I had to rewrite this equation, keeping my first part the same, but taking this 2u1 and splitting into 2 separate u1s, and keeping that the same, I hope you would recognize that this piece is our arithmetic sequence, un in other words. So another way I can write it is n divided by 2 times u1, that's this u1, and all of this is un. So for a bit of a shortcut, if I know the first term and the last term, I can find the sequence really quickly by adding them together and multiplying it by n over 2. If we look at our previous example for just a second, we had 7, 21, 28, dot, 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 up to, what was the last one, 175? Yeah. We said there was 25 terms in the sequence. So if I want to do S25, I can do it really quickly by doing 25 over 2 times U1 plus UN. In other words, 12.5 times 182, which I put into my calculator, and I get 2275. It's just faster if we know the first term and the last term. And the key there is you have to know the last term. Okay. All right, let's try some more problem solving. Here's one for you. I got a bunch of terms. I want to know what it adds up to. I notice that I have the first term, U1. I notice I have the last term, UN. I can use my shortcut if I were to know how many terms there are. To find my number of terms, I can use my UN equation with the U1. I have to solve for it. So 4374 equals 2 plus n minus 1 times 4. So if we expand our brackets, we'll get 2 plus 4n minus 4, or in other words, minus 2 plus 4, 4n. Add them together, we get 4376 is 4n, and n comes out to 1094. So I want to find the sum of this 1094 terms. I can do that the fast way by using my first term and my last term. Okay, we'll have to divide this, 547 and 4376. Into my calculator, pretty big number this time, 2,393,672. And there we go. Okay. Some problem solving for us. Word problems. How do we apply this? So we have a theater. It's got 20 seats in the first row, 21 in the second, 22 in the third, and so on. If the theater has 40 seats in the last row, determine the total number of seats. So in other words, we have to add the first row, plus the second row, plus the third row, plus the however many rows there are, until we get to the last row. Well, that looks awfully familiar now, right? Once you take the words away and think of it as just a sequence of numbers, it's exactly what we've been doing. I don't know how many numbers there are, terms, so I'm going to solve it. My difference is 1. It's kind of nice to work with. So I'll solve this equation. It turns out there's 21 rows altogether. I want to find the sum of 21 rows. I can do that. 21 over 2. First term, last term. 10.5 times 60 will give me 630 seats. Okay. Once we take away the words and just think of it as a pattern of numbers, it causes less confusion. And last one. Michelle, she's a marine biologist. She accepted a job that pays $46,000 in the first year, $56,000 in the 8th year. Her salary is an arithmetic sequence with 8 terms. What raise can she expect each year? So they're telling us some information. They're telling us U1 is 46850, and they're telling us U8 is 56,650. And they're telling us we have an arithmetic sequence with 8 terms, n is 8. What do they want to know in part A? What raise? Her raise is the difference from one year to the next. So we're going to have to solve for it. We can solve things using the U equation. UN equals U1 plus n minus 1 times D. What do we know? We know, well, first term is 46,850. We know the 8th term is 56,650. So if I use that one as my UN, the last term, it would be term number 8, 8 is n, I can solve for D. To do this, I'm going to put the numbers on one side, 56,650 minus 46,850 equals 7D. If I subtract, I get 9,800 is 7D, and divide by 7, and D will be $1,400. There's her raise each year. Okay, part B. What will her salary be in the 6th year? I can figure that out. That's just U number 6. 46,850 plus 6 minus 1 times D. We just figured out D was 1,400. And into my calculator that goes, and I think her salary in the 6th year would be $53,850. Using our equation. In what year will her salary first exceed 50,000? Well, it's a pattern in my sequence again. I need to figure out what term number that is. So this time I'm going to put 50,000 in. I know I start at 46,850. I know I have n minus 1 times d. D is 1,400. I just got to solve for what number in the sequence we're at. So let's rearrange. Actually, let's expand our brackets first. 50,000 equals 46,850 plus 1,400. N minus 1,400. Now we'll rearrange. 50,000 minus 46,850 plus 1,400 equals 1,400 N. Collect it all up, and I got 4,550 equals 1,400 N. If I divide by 1,400, I end up with 3.25. So how do I answer that? Well, it depends on when she gets raises. So if she can get raises partway through the year, she will pass 50,000 during the 3rd year, or if she only gets a raise at the beginning of the year, which is more likely, at the beginning you get a new raise, beginning you get a new raise, we could say then by the 4th year. And we can't say the 3rd year because at the beginning of the 3rd year she hasn't got to 50,000 yet. It doesn't happen to partway into the next sequence, right between the 3rd and the 4th term. Okay, I got one more part here, letter D. What is the total amount that she will earn in the 8 years? Total, that's a key word. That's an S equation, S8. And because I know the 1st term, and I actually know the 8th term, we were told that in the question, right? 1st term, 8th term, I can use my shortcut. I can use U1 and U8 and use my shortcut. So U1 is 46,850, U8 was 56,650. Into my calculator that goes 4 times 103,500, and she's going to earn a total of 414,000 over the 8 years based on salary. Okay, so there's arithmetic series, the sum of a sequence. If you want to know things about the equation itself, you have to use your U1. If you want to find the sum of it, you can use your S1. And I would use a shortcut wherever possible. Some homework you should try and make sure you know what's going on here. And we'll move on to our next topic tomorrow.